right, so let's get started. So in next around 40 minutes, we will dive a little bit deeper into how the event loop works in JavaScript. And hopefully after this 40 minutes, you know how set timeout really works in detail. So really short introduction to myself. My name is Christian. I've been working as a software engineer for like 14 years now. Started back with Java, and then like 8 years ago when Angular 2 was released, I switched over to TypeScript, JavaScript, and Angular. And since then I'm working as a full stack engineer. So I'm also a trainer on the side. I give different trainings. I also really enjoy to speak at conferences, also listen to other people speaking at conferences and sharing their passion. And I recently, like 5 months ago, started to also do some content on YouTube. So if you're interested in really advanced TypeScript stuff, which I think is really some kind unique on YouTube, what I do, you can find a link to it on type.rocks. There is a link to LinkedIn, GitHub, but also to my YouTube channel. So without further ado, let's get started with the talk. So what I normally do is, I normally do in my talks like only live coding, so that we build something. But in this special case, we have to do some slides because we need to know like a basic understanding, we need to have a basic understanding how the event loop itself works before we can dive into the code. So this is why we will start with what's the difference between an engine and a runtime. And we will then look into it why we need the event loop and how the event loop connects these different parts of the runtime. And so I have to explain all the different parts to you, and then we will do some live coding. We will see like how the timeouts and so on work in real code. And at the end, we will have some a small quiz where we can see if I did a good or a bad job to tell you some stuff. And you can also win some stuff from Switzerland, so some chocolate from Switzerland. But sadly, only the first 40 people can enter this quiz because it's somehow restricted. I don't know why, but we will get to this when we see it. So let's get started. And the first thing is about the difference of an engine and a runtime. Now, this is often used interchangeably. Yeah, we have this JavaScript engine, this JavaScript runtime, but these are two different things because I will show you first what an engine really is. And an example for an engine is SpiderMonkey. SpiderMonkey is used for the Mozilla Firefox. And this one here is a WebAssembly compiled version of the JavaScript engine SpiderMonkey. This means that you also can go to this website, Mozilla SpiderMonkey GitHub.io SM demo, and you can just play around with it. So when we say, for example, we have an I here, 0, and we say I++, and we have our console log here, and we print this out, we can see this clearly works. But what happens when we, for example, use set timeout here? We can see we get an exception here, set timeout is not defined. Now, maybe you have already seen such errors when you try to use window in Node.js. For example, when we use window here, we get window is not defined. And the same also happens when we say, for example, fetch, we also get this. Now, why is this? Because this stuff like set timeout, window, all this stuff is not available in the engine. This is stuff which the runtime provides. So what's the difference here? The engine, when you heard about like the ECMAScript standard or ES6, ES23 or something like this is this standard which an engine needs to implement so that it is conforming to this ECMAScript standard. So a good example would be also V8, which is used like for Chromium browsers or for Node, SpiderMonkey, which is used for Firefox. But in there are no such things as set timeout, fetch, and so on. When you look into the ECMAScript standard, there is nothing in there, there is not one entry for this. Because this is what a runtime does. A runtime, for example, Node, hosts an ECMAScript engine. So this means that it packs an engine and it adds additional functionality. For example, in the browser, it's web API access, DOM access, file access, and so on. Now, the difference to the engine is that it has no restrictions. So this means that you can add any features you like. So for example, you can, for a long time, fetch was only available in the browser, but not in Node, because this is not something, as already mentioned, which is defined in the engine, but every runtime can define their own kind of implementation. Now, this is also why each runtime has to implement its own event loop, because this is not something which is in the engine, because the engine does not care about the event loop, because it does not need it. So let me show you what's the issue and why do we need the event loop in our runtime. So I will go here on a really simple website which I've created, and this has just 2 buttons. When I click on this fast button, we can see the background changes immediately. Now, when I keep this button pressed, we can see the button turns red, and as soon as I release it, the background changes again. Now, what happens if I click here on the slow button? I click on it, and I'm no longer clicking on it, but the button stays red, and the background does not change its color. And this is because I'm running a busy loop where it's just like counting a number to an even higher number, and this takes some time. And during this time, the whole UI is frozen because this is single-threaded. So this means that as long as this busy loop is running, nothing can repaint in the UI. So the complete UI thread is frozen. And this is not what we want. We want that we can do some stuff in the best case asynchronously so that the user still can input stuff in the UI. So this is why we need the event loop, because let's say we are in Node and we have like this fetch sync call. This is really slow, and we have like a console log before, then we assign the result of this fetch sync to our variable, and then we have this console log after. Now this would block the whole Node process because it would wait until the synchronous fetch is done. For example, when you do like a read file sync, this also blocks the whole application. Now, to go against that, we need to use an asynchronous approach. So we say instead, we have, for example, a fetch async, we have a callback, and as soon as it's done, our function calls this callback, and we can then handle the result. Now, this of course works nicely, but we need some tool which takes this result and says, well, now it's a good time to evaluate this. Because you can't just, when you're running other code, just as soon as this result comes back from the server, immediately execute it. Because you're maybe, let's say you are in a loop, in a busy loop, you're counting something, and then you can't just execute something else immediately. And this is exactly what the event loop does. The event loop is responsible for orchestrating which task to run at which position and at which point in time. So we now have to see what kind of elements the event loop connects. So we get started with the call stack. Now, what is the call stack? The call stack, simply told, is just the part where the code lives, which is currently being executed. So let's say we have here our call stack, and we have our code here in our file. Now, the first thing what happens is the first line of code, our console log first, gets pushed onto the call stack. It then gets evaluated, so it gets executed, and when it's done, it gets popped off the call stack. Now, the next thing, let's say we have our second function, we call this second function. Now, the second function itself internally has another function call, let's call this inner1. And so it calls this inner function, and this also gets pushed onto the call stack. And then this inner1 function has another function, this inner2. And as soon as this inner2 function is done, it gets also popped off the call stack. When the inner1 is done, it's popped off the call stack. And then when the final function is done, it gets also popped off the call stack, and it's ready to execute the next thing. But it's important to understand that the call stack, you just not add new stuff to the call stack, like this third function, as long as there is still stuff on the call stack. The call stack has to be empty before you're allowed to push other stuff onto this call stack. Because, as mentioned, this is just where the currently running code is, and you don't want to interfere with the currently running code. So it then also, the third one, pushes on the call stack, and then when it's done, it removes it. Now, this is for the stuff which is synchronously like pushed onto the call stack, but we need something which allows us to store these results of this asynchronous calls. We have seen prior, we have this fetch, for example, and we get the result from an HTTP request. And this result, we have to store this result somewhere to execute it later when we have time, when the call stack is ready. So this is why we need queues. Now, there are different kinds of queues in different runtimes. For example, the browser has other additional queues, but like a simple approach to show it is that we have 2 queues. The first queue is the so-called macro task queue. The macro task queue you can think of as a simple first in, first out queue. So this means that the first thing you put in there is also the first thing which leaves the queue, which gets evaluated. Now, what gets pushed on there? we push on there the results of the web API callback handlers. So for example, when we have a set timeout, then we push the result of this set timeout, this arrow function here in this case with this console log hi, we push this result onto our task queue as soon as it's ready. Now the same is, for example, with event handlers. When you add an event listener in your browser, this also gets pushed onto this macro task queue. Now this has the lowest priority of all the queues. So this means if there is something in another queue, then this will not get evaluated. Only when all the other queues are done, then this one will get evaluated. Now, because we have a low priority queue, we also have a high priority queue. And this is called microtask queue. And this is the same kind of queue. It's also first in, first out queue, but it's much more restricted what we put on there because we are only allowed to put 4 different things on there. The first thing is promise handlers. So when you have a function which returns a promise, the result of this promise, like when you have a then handler or a catch handler, this gets pushed onto the microtask queue. Also, when you have async await, this also gets pushed, the results also gets pushed onto this queue. Now you are allowed to push your own microtasks onto the queue in Node, for example, if you use queue microtask. There you can just pass in a function, an arrow function or a normal function, and this will then also get added to the queue. Now one interesting other API which also allows this is mutation observer. And this is used in the browser. You can use a mutation observer to listen for changes in the DOM. For example, if elements were added, removed, attributes changed, and so on. Now this is the high priority queue. So this means as long as there are elements in this kind of queue, the other queue stays untouched. But we will go into when executes what in just a minute. Now we have seen this micro and macro task queue. Now how does this work how can we pass really elements to it by using the web APIs? Now, there are 2 different kinds of web or C++ APIs, and this is the functionality which the runtime provides. As mentioned, like set timeout, fetch, in this case here, local storage, document, and so on. These are all objects or functions provided from the runtime itself. So there are 2 different kinds of APIs. Of course, there are synchronous ones, like in this case, document query selector. This just immediately returns to you. There is nothing pushed onto any queue. This is just like if you would call something synchronously in your own code. But there is also this asynchronous stuff in the web or C++ API. This is, for example, fetch, where you get back a promise, and this promise then gets pushed onto the micro task queue. Set timeout is a callback, so it gets pushed onto the macro task queue. So we will see how this works right away. Let's say we execute a set timeout. So we have a set timeout in our code, which has a console log hi in there as an arrow function and a delay of 20 milliseconds. Now, the runtime executes this code and it runs this set timeout in the web API part of our runtime. Because in this web API part, you can run stuff multi-threaded because this is not in the JavaScript engine, but this is in its own part of the runtime. So what this then does is it just triggers a timer, and after this 20 milliseconds, it takes the result of this set timeout, so this arrow function we have here, and push it onto the task queue. And this is exactly the point why set timeout not gets executed immediately after the delay is done. Because the only thing what happens is after this delay, it gets pushed onto the task queue and is ready to being executed when there's time. But there is no need that it gets evaluated immediately. So for example, when you have a set timeout and then you have a busy loop in your code, which never ends, this set timeout will never execute because the application will never reach the point where it can execute the tasks in your task queue. So this is why it's not like when you say you have a set timeout of 2 seconds, this immediately executes after 2 seconds. You can't rely on that. And also what we see here is that only the results of our set timeout call gets pushed to the task queue. As long as the timer is running, or for example, when you do a fetch call, as long as this request is still ongoing, there is nothing in this task queue. In there are only the results which are ready to being executed. So this means, for example, if you have a long-running fetch task, then this will not get pushed immediately to the task queue, but only when the result comes back. But we will see this in code later. So And this is exactly where the event loop comes into play, when to execute what kind of task. Because the event loop itself is really simple, because it has at its core, it is just like a state machine. It first checks, is the call stack empty? Is there something still running on the call stack? If there is still something running on the call stack, then it just it does nothing. It waits until the call stack is empty. As soon as the call stack is empty, it then checks the microtask queue, so the ones which stores the promises and so on, if there are tasks there ready to being executed. If there is a task, it adds it to the call stack. And then it checks again, is the call stack empty, and so on. Now, only if the microtask queue is empty, then it checks if there is stuff in the macrotask queue. So if there are many elements in the microtask queue which need to be evaluated, it takes a huge amount of time until the macrotask queue is even starting to evaluate. So we will also see this in code, what can be the issue with this. But this is basically how the event loop really works in simple terms. Of course, if you go a little bit deeper into it, you see that we have different kind of sub queues and stuff, which different kind of ticks and so on. But this would be way too deep in the detail for really to have an understanding for a normal developer, like everyone, 99% of us are, to understand how this works. So this is basically the only thing you need to know from this whole presentation. If you want to know how the event loop works, this is the slide you need to know, and maybe what these queues are. But let's now see this in code, because we now have seen this, of course, in a little bit in theory, but let's see this in code. So let's switch over here to VS Code. Now we have still here, I have an image of this event loop so that we still can see what happens here. Now, I've created a small plugin for VS Code. This is called TypeScript Worksheet, and you can use it for any runtime you like, for Node.js, Dino, or Bun. And what it does is it just shows you your code which you executed immediately in your VS Code. So let's say we have here a set timeout, and we have here a console log, and we say here timeout. And we have here our console log sync. Now, you can run this from the command palette, and we can see we get the result in here, and we see also the order in which this was evaluated. So what we see here is, at first, set timeout was executed. Of course, because this just calls into our web APIs, and then it gets popped off the call stack. The next thing what happens is, console log sync gets evaluated, and it prints out sync. Now, at last, console log timeout gets executed, because this was added to the macrotask queue. Now, as soon as there is nothing more available to be done on the call stack, the event loop checks, is there anything in the microtask queue? There is not, so it checks for the macrotask queue if it has tasks or not. Yes, it has, so it pushes it onto the call stack. So this is how you can see, even with a delay of 0 milliseconds, this gets evaluated after all our synchronous calls. Now, the same thing also happens with promises. When we have a promise and we use promise resolve to immediately resolve our promise, like this, and we run this, we can see that now the console log is printed out first. Then our promise resolve is resolved here, because this is pushed to the microtask queue. So the microtask queue gets evaluated before the macrotask queue. So this means that even when we put this in after our set timeout here, this gets executed first, because at this point, there is a task in the microtask queue, but also in the macrotask queue, but the microtask queue has the higher priority. But of course, this only works, so this microtask queue only gets evaluated first if there are elements in there. So let's say we have a fetch here, and we have an HTTP google.com here, and we have this then like this, and I run this. Then we can see that the set timeout gets evaluated first, because at this time, fetch was slower. It was waiting for the response to come back, and at the time where the first event loop tick was running, there was nothing in the microtask queue, because the request was still running, and only the responses, so the results of our promises, get added to these queues. This is why the set timeout was executed first. So this set timeout here is not waiting for all ongoing other promises or fetch requests to be run to be finished, but it just checks if there is something in the queue or not, then it executes it, or in the macro task queue. So, but this is also why we can starve our macro task queue. So let's say we have here a function, and let's call this function queue again. Now what this function does is, we just call queue again in it, we just call queue microtask in it, and in there, we then call queue again. So what we do is, this queue microtask just queues another task into our microtask, and then we will see what happens. So I will run this in the console, because otherwise it maybe could crash my tool here. So I will use index.js and I will run it. But of course, I have to call this first, and I will then run it. And we see here, it only prints out sync. It doesn't print out timeout at all. Why is this happening? Well, because I call queue again here, then I call console log sync. Sync gets printed out, and then this queue again is pushed to the microtask queue. Now in the microtask queue, the event loop checks, okay, now there is an element in it, a function, I will execute this. So it executes this on the call stack, and it runs this queue again function. This pushes another microtask, another microtask in our microtask queue. So there is this endless loop of adding new elements into it, and we never reach the point where we even check if there are tasks in the macrotask queue. So when you have stuff like this happening, and you also see you don't get like a stack overflow or something like this, because this is not pushing something more onto the stack, because this is done asynchronously. So it's always, the stack will always be empty and a new element is added to it. So if there is something happening like this in your code where you don't get like a maximum call stack exceeded or something like this, it maybe has to do with something pushing itself to some kind of queue again. And because of that, it will never reach this maximum call stack, but it's still like in this busy loop. So let's stop this here. Now, what we also, of course, can do is we can starve our microtask queue, because let's just remove this here. And let's just say we have something really simple. We have this promise resolve here, and we have resolved. And now after this console log sync, I just have a while loop, and I say while true. And I say here, I leave this empty. And when I now run this, we will see exactly the same. We will see that sync gets executed, but this promise resolve never gets resolved, because we have this busy loop here, which always keeps something on the stack. So the stack is never empty. So this means we will never reach the first queue here. So just because something is pushed onto some queue before does not mean it gets evaluated if you block this, if you block your call stack. So this is like a really simple approach. There is other stuff you could do. For example, in Node. Node knows also stuff like, or the browser, like set immediate, which you can push something to the first position of a macrotask queue. But I will not show you this in detail, because this is like deprecated and you shouldn't really use it. But there is also stuff where you can change how the order of these queue work. So if you're interested, you can just Google it. But I will leave this here as it is, because I think it would be a little bit confusing, because it should not be, it's not best practice to use this anymore. So let's go back to the presentation. If you want to play around with such stuff, there are two cool examples you can use. The one is from Loop. Loop is like 8 or 9 years old, and it's a really cool tool which shows you how the event loop works like in real time. But you have to take into consideration that this loop there, this does not contain the microtask queue. Because back then, I don't think that the promise were a big thing there, and they only added the callback queue in there. So if you use, for example, promise resolve in this example, where you can use it in real time, this will not work. But if you want to just see how the callback queue works, you can check out the first one. The second one is it's a JavaScript Visualizer 9000, it's called on their website. And it's really cool. It also supports the microtask queue. But the issue with this is that the visualization is not completely correct, because it shows that something is pushed to the micro or macro task queue immediately when, for example, set timeout is called. When you have set timeout 2 seconds, it will show you that immediately you see the result in the queue, but this is not the real case. It only gets pushed into the queue after 2 seconds. So, but for like basic stuff, you can check out these 2 websites. They're really cool, and they give you also a good understanding how they work in real code. All right, so let's now go over to the quiz. We have to. I will switch over. I hope my website, my hotspot is working. So I'll switch over to it. So I don't know if you know Kahoot. You can just scan this QR code. Only the first 40 people can enter because it's too less often. It does not have that many free tiers. Oh, interesting. It somehow does not stop. I was thinking it stops at 40. Okay. So, yeah, let's see what happens when there are more people coming in. All right, so I think I will start now. So how it works is you will always have like between 30 and 45 seconds. Will have like a snippet of code, and you have to just tell in what order the console log gets printed out. Really simple, but the code maybe isn't that simple, but okay, player limit, okay, 50, nice, okay. So let's get started with this. So the question will be on the screen here to look at, and the possibilities to answer are on your screen. Nice, 28 had it right. So let's first see why this is the case. This was a little bit of a hard one because set timeout does not care if you put in negative numbers. If it's just 0 or less, it just puts it into the queue. And we can see here, of course, we have a timeout of 0 milliseconds, so it pushes in the function into the macro task queue. Then we have the second set timeout of 2. It pushes this one into the macro task queue, and it prints it out in this order. Exactly. So let's go to the next one. 888, nice. It's also about who's the fastest, because otherwise it would be impossible when more people have the same amount of correct answers. So let's go to the second one. It's always the same question. All right, let's see. Let less people had it right. So let's see why this is the case. So 3 to 1 was the correct one. So let's see why this happens. We have this set timeout, which just pushes this pushes this arrow function on the macro task queue. Then we have this new promise, and because we have this is a promise, this pushes this console log 2 arrow function, this result console log 2, onto the micro task queue. The next thing is it just executes console log 3, so console log 3 is immediately pushed onto the console. Then it checks, is there a microtask in there, or is there a microtask available? And there is this promise in there, console log 2 with the arrow function, and executes it. So it pushes the 2, and then it checks, is there something in the macrotask queue? So it pushes the 1. So that's why it's 3, 2, 1. This way of creating the promise, I know this was a little bit tricky, but the other way would maybe been too easy. So Mary is currently. All right, yeah, most of you had it correct. So let's first see why this is the case. So we, of course, again, we have this set timeout of 1. So we push this onto the macrotask queue. We then have this fetch, which we had also like in the demo, because this fetch does not get pushed immediately onto the microtask queue, because it first evaluates it in the web API part of the application, of the runtime. And only when it's done, it pushes it to the microtask queue. So this means that this, in this case, is the last thing which gets evaluated. So the set timeout then, console log 3, gets pushed to the macrotask queue. And now the event loop checks, okay, what is in the microtask queue? Nothing is in there because the fetch is still running. So the set timeout of console log 1 gets printed out because it's the first one in the queue. And then the next one is the second set timeout with console log 3. And that's why, in this case, the microtask is at the end printed in the console. So let's go to the next one. It's really close here. All right, so let's go to the next one. I know the time's a little bit short, but I will keep it that way so that it's not that easy. All right, so this looks like quite a difficult one. So let's see why it's 1 and 3. So we have this set timeout, right? This set timeout pushes this function onto the macrotask queue. So it's now the first element in the macrotask queue. Then we print out console log 1, right? So we just print it out so it's immediately there. Then we have this set timeout of console log 2. So we push this also onto the macrotask queue. So on the macrotask queue is now this run sync arrow function and this console log 2. And now nothing more happens because this function run sync is just there because we run it. And now it checks, is there something on the microtask queue? No, there isn't. Then it checks if there is something on the macrotask queue. And we can see now this macrotask queue contains this run sync. And this run sync, what it does is it just prints this console log 3, and then it's a busy loop because 1 is always smaller than 2. So you never reach any other queue again, not even a microtask queue, because this is the same what we have seen when I've shown you in the demo when I have this while true. It never exits the call stack. It just stays in there, always active. So this means that we will never reach this set timeout console log 2. So that's why we only print out 1 and 3. No, other people are up there. So this is the second last one. I think this is the craziest one. I think that you have more time for this. All right, yeah, most of you had it right. Nice, really nice. Because always when I explain it, I always have to think about this too. So let's see why this is the case. So the first thing what happens is we have to set timeout. This just pushes this whole function onto the macro task queue. Then we have to set timeout, which puts this task onto the macro task queue, this function here. And then we have this promise resolve. So this promise resolve gets pushed onto the micro task queue. Then the event loop kicks in and it looks, is there something in the call stack? No, there is not. It checks for the micro task queue and it sees, oh, there is this function there ready. And let's execute this. And it prints number 6. So this is why 6 is at first. Now it checks, is there something in the macro task queue? Yes, there is, because we have this function in there, which was added immediately. So it executes this. What does this? It logs 1. So this is why we have 1 here. And it just calls set timeout again. So it pushes this whole function into the macro task queue. And then what it does, it checks, has it something else in the macro task queue? Yes, it has, because this set timeout here was also added before. So it's before in the queue. So I execute this console log 4 and print it to the console. And then what it does is, in this macro task, it queues something into the micro task queue. So it queues this promise resolve 5 with the console log into the queue. And this is why it's then, when the next event loop check comes in, it finds something in the micro task queue. So it then evaluates this here and it prints out number 5. And then it looks again, okay, so something in the macro task queue, yes, there is. It finds this function here. So it sees, okay, I run this. It pushes another thing in the macro task queue, prints out the console log 2. This is why we have the 2 here. And then the last thing it checks, is there something more in there? Yes, there is. We have this last set timeout here, this console log call, and it prints it to the console. But really, really impressive that so many of you had it correct in the short amount of time. Really, really crazy. So let's see. Let's now go to the last one. The balance checking is high up there. But this is the last one. This is not that crazy, I think, but I can't really remember. Nice, pretty nice. So why is this 1? Let's see this. We have this function, which when we call it, it just creates a promise. And then when the promise is done, it just runs this run it function here again. And we have this console log 1 and then run it. And then this set timeout. But we don't really have to care about everything what happens in here, because let's see what happens. We have this console log. This prints out 1. And then we have this run it function. This run it function just calls this promise resolve here. And then in the then block, it has this arrow function there. And what happens is this pushes it into the microtask queue. And then the event loop checks again, is there something in the microtask queue? Yes, there is. There is this function which executes run it. So I run it. So I call it. And then this means that it pushes another promise into it. And this is exactly like this starving we have of the macrotask queue. It never reaches this queue because we always queue another promise into our microtask queue. So this is, of course, this is like always like this endless loop we had also in the demo. All right, so let's see who the winners are here. Woerz on the 3rd place. Minus. Oh, okay, it changed. So the 3 people who won, they all received some sweets from me, some crackers from Switzerland. So you can then come up after the talk, and hopefully you really are the person who won this. Otherwise, it wouldn't be that fair. But let's go back into the presentation. So if there are now any questions, of course, you can ask them now, but of course you can also contact me on LinkedIn or come back later to me and ask me some questions. But are there currently any questions? Maybe there are. I know it was a little bit much information in a short amount of time, but is there anything? All right, so if not, then I would like to thank you for being here. Wish you an awesome conference. As mentioned, when you want to stay in contact, go to type.rocks. And for the 3 people who won, just come over and take your gift. Thank you.